the range of values for x for which A inverse exists. So first thing, it tells us that A is equal to 1, x minus 1, 3, 0, 2, 2, 1, 0. And so to determine the range of values for A inverse to exist, A inverse will exist if the determinant of A is not 0. The determinant of A cannot be 0. All right, because if the determinant of A is 0, it's going to be singular. All right, so we want where the determinant of A is not 0. Now to find the determinant of A, we can use column 1 or we can use row 1. I'm going to use column 1. So using column 1, we're going to get that the determinant of A is going to be equal to 1 times the determinant of going to be 1 times the determinant of 0, 2, 1, 0 minus 3 times determinant of x minus 1, 1, 0 plus 2 times the determinant of that's x minus 1, 0, 2. Nice and easy. That's the determinant of A. So what are we going to get? Now, product of the leading is 0 minus the product of the non-leading. And so 2 times 1 is, that's what? 2 times 1 is 2. 0 minus 2 is minus 2. And we have minus 3 times x times 0 is 0. 1 times minus 1 is minus 1. So it's going to be minus 3 times 0 minus minus 1, which is plus 1, plus 2 times, this looks like 2x minus 0, and this can't equal 0. All right. So solving this now, we're going to have minus 2, minus 3, which is minus 5, plus 4x, and this can equal 0. So what you're ultimately telling me then is 4x cannot be equal to 5. And so x cannot be equal to 5 over 4. But then that don't give us the range. Remember, they wanted a range. So since they wanted a range, we just have to tell them that x can either be less than this or greater than this. So x can either be less than 5 over 4, or x is greater than 5 over 4. That's the range. Now it says, given that the determinant of A times B is negative 21, show that x is 3. So find the determinant of A times B, and it's negative 21. All right, given that the determinant of A times B is negative 21, well, I was trying to think of a shorter way to do it, but I'm just going to find the product of A times B. The product of A times B I know it sounds very long to work out that the product of A times B, that's 1x minus 1, 302, 210, and it's being multiplied by 1, 2, 5, 2, 3, and 4. And this is 1, 1, 2. So the product of A times B, so the product of A times B is going to work out to be row times column, row times column. So AB is going to be 1 times 1. So you get 1 times 1 plus x times 2. 1 times 1, which is 1, plus x times 2 plus minus 1. So that just becomes 2x goes here. Then row times this column is 2 plus 3x minus 1. But the 2 minus 1 is 1. So it's really 1 plus 3x. Then row by column, it is 5. This column becomes 5 plus 4x minus 2. But 5 minus 2 is 3. So it becomes 3 plus 4x. Then it's going to be row by column. So that's 3. Row by column, that's 3 and 0 and 2. That's 5. Row by column is 6 and 0 and 2. 6 and 2 is 8. And then row by column is 3 times 5 is 15. 15 plus 4 is 19. And then row by column, 2 times 1 is 2, plus 2 is 4. That's 4. Then row by column is 4, plus 3 is 7. Row by column, that's 7. Then row by column is 10, 14. So this is 14. This is AB. All right, and so the determinant of AB is equal to, the determinant of AB is now, as the determinant of AB, it's going to be, we're going to be using column 1. I like to use column 1. So it's 2x times 8, 19, 7, 14, minus 5 times the determinant of 1 plus 3x. And then that's supposed to be 3 plus 4x. All right, 1 plus 3x, 3 plus 4x, 7 and 14. Nice. Then we're gonna have, this becomes plus 4 times the determinant of 4 times the determinant of, cancel out this. This is now 1 plus 3x. 1 plus 3x times 3 plus 4x. One plus 3x times 3 plus 4x. 8 and 19. All right, and remember they said that the determinant of AB was negative 21. So with that being said, let's go ahead and calculate. So now we're saying that negative 21 is equal to 2x times 8 times 14 is 112 minus 19 times 7, 133, minus 5 times 1 plus 3x times 14, that's 14 plus 14 times 3x is 42x, minus 7 times 3 is 21, minus 7 times 4 is 28x, plus 4 times 1 plus 3x times 19 is 19, plus 19 times 3 is 57x, minus 8 times 3 is 24, minus 8 times 4 is 32x. All right, nice. So let's simplify it. We have minus 21 is equal to 2 times 112 is 224x. 2 times minus 133 is minus 266. Then we have minus 70 minus 5 times 42 is minus 210x. Minus 5 times minus 21, that becomes plus 105. Then 5 times 28, that's plus 140x. Plus 4 times 19 is 96. 76, sorry. Plus 4 times 57, 228x. 4 times 24, I'm positive that one is minus 96. Then minus 32 times 4 is 128x. All we need to do is group our x terms. So let's group the x terms. I'm going to highlight the x terms in red. 224, 210, 140, 228, 128x. So putting those together, we're going to get minus 21 is equal to 224 minus 210 plus 140 plus 228 minus 128. That's 254x. Then adding up all the numbers, I have minus 266 minus 70 plus 105 plus 76 minus 96. I get minus 251. Bringing it over, 251 plus 21. That's not giving me, something went off. Let's check again. X should be 3. X should be 3. So we need to show that X is 3. Let's check what we did. Make sure we didn't make any mistake. 2x. That's 8, 9. That's good. Minus 5 times. This is fine as well. Plus 4 times. And this is good. So we're checking this now. It is 2x times. This time minus this. All right, let's remove this line and simplify from here. Just going to simplify inside the brackets first. 2x into 112 minus 133 is minus 21. Minus 21 times 2, that's minus 42x. Then I'm going to simplify in that bracket. to be 14 minus 21 is negative 7 times minus 5. That's plus 35. 42 minus 28, that's 14 times negative 5, that's minus 70x. Then I have 19 minus 24 is negative 5 times 4, that's minus 20. Then I have 57 minus 32 times 4, that's 100. X, let me see now, minus 21 is equal to minus 42 minus 70 plus 100, that's minus 12x. Then I have 35 minus 20 is 15. And so when I subtract 15, I get minus 36 is equal to negative 12x. So I divide both sides by 12, and so x is 3. So that proves it. X is 3. All right, so this takes care of it. X is 3. Nice. X is indeed 3. All right, finally we get x to be 3. It says, hence obtain A inverse. Hence. Okay, since we know what is x now, and so we know that A inverse is going to be equal to 1 over the determinant of A times the adjoint of A. That's going to be A inverse, 1 over the determinant of A times the adjoint. Now we already know A inverse. Remember we said that, we mean the determinant of A. We said that the determinant of A is this, minus 5 plus 4x. That's the determinant of A, minus 5 plus 4x. And so the determinant is really going to be minus 5 plus 4 times x, which is 3, so it's 7. So the determinant is 7. So the determinant is really 7. So it's 1 over 7 times the adjoint of A. So let's find out the adjoint of A. To find the adjoint of A, we're going to have to use a cofactor matrix. And then transpose the cofactor. And transpose the cofactor. That's going to be equal to 1 over 7 times. All right, so now we have this now, AB. Cofactor of 1 is going to be 0, 2, 1, 0. This is a plus. We have a minus here. And it's going to be cross out this and cross out this. That is 3, 2, 2, 0. 3, 2, 2, 0. Then go around here again. Cross out this, cross out this. So it's going to be 3, 0, 2, 1. 3, 0, 2, 1. Then crossing out the 3, it's going to be x, but x is 3. So it's going to be x minus 1, 3 minus 1, 1, 0. Then in the middle, it's going to be 1 minus 1, 1 minus 1, 2, 0. Then over here, it's going to be 1 x, so x is 3, 1, 3, 2, 1. Finally, down here now, it's going to be crossing out the 2, it's going to be x minus 1, which is 3 minus 1, 0, 2. Oh, and I forgot the sign. This is plus, minus, plus, minus, plus, minus, plus. So right here is going to be crossing out the minus now, crossing out 1. It's going to be 1 minus 1, 2, 0. Then finally here, it's going to be 1 x, x is 3, 2, 1. So now we have the cofactor matrix. So the cofactor matrix is going to work out to be 0 minus 2 is minus 2. This part is going to be 0 minus 4 is minus 4. Minus of minus 4 is 4. And here is going to be 3 times 1 is 3 minus 0, that's just 3. 3 times 0 is 0. Minus 1 is plus 1, but then the minus make it be minus 1. We have 1 times 0 is 0. Minus 2 is positive 2. Then we have 1 times 1 is 1. Minus 3 times 2 is 6. 1 minus 6 is 5. 1 minus 6 is minus 5. So minus 5 is 5. 3 times 2 is 6. So we get 6 here. Over here we get 0 minus 2. So this is just minus 2 here. Then finally here we have 1 times 1 is 1. Minus 6. All right. Just to make sure this column is right, crossing out the 1, it's going to be 1 minus 1, 1 minus 1, 3, 2. So this is not, this right here should have been 3, 2. Sorry, 3, 2. And here should be crossing out that, it's going to be 1, 3, 3, 0. 3, 0. All right, that should be fine now. So this shouldn't be minus 2. This is 2 minus 3. So this is negative 5. Then 1 times 0 is 0. 0 minus 3 is minus 9. And then we transpose this. So now we can write what is A inverse. A inverse is 1 over 7 times. When you transpose it, you're going to get minus 2, minus 1, 6. This looks like 4, 2, negative 5. Then you're going to get 3, 5, negative 9. Nice and easy, soft. Now we can go to the final question on the paper, which is question 6. Question 6 says, show that the general solution of the differential equation y prime plus y tan x sec x equal y sin x plus c cos x